All right, let's dive into something we do dozens, maybe hundreds of times a day without even thinking about it. We're going to follow a single piece of data, what's called a packet, on its incredible journey from the moment you click a link all the way across the internet and back to your screen. It's going to be a wild ride.
So you click a link, right? A photo, a video, anything. And boom, it just appears. It feels like magic, doesn't it? But it's not magic. Not at all. It's this unbelievably complex, high-speed race through a maze of devices, rules, and cables. So what's really going on in that split second? Well, that's exactly what we're going to break down today.
Okay, so here's our roadmap for this whole journey. First, we'll cover what a network even is. Then, we'll look at your local connection, the rules of the road for data, the massive internet highway itself, what happens when our data arrives, and finally, how we measure how fast it all happened. Let's get started.
All right, section 1, what is a network? Before our little packet can even begin its adventure, it needs a place to start. It has to exist on a network. But, what does that word even mean, really?
When you boil it all down, it's actually pretty simple. A computer network is just a group of devices, computers, phones, you name it, that are all connected so they can talk to each other. That's it. The entire goal is just to exchange data and share resources. Think about sharing a printer in your office or, watching a video from a server halfway across the world.
And here's the crucial part. Every single one of those devices is called a node. And just like your house needs a street address for mail to get to you, every node on a network needs its own unique address. Your phone, your laptop, your smart fridge, they all have one. Without that unique address, sending information to the right place would be, well, completely impossible. It'd be total chaos. Okay, so we've got the big picture. Now let's zoom way in. The journey for our data packet starts right where you are, inside your home or office. This is your local connection. So this is what we call a local area network, or LAN for short. This is your private little network. It's what connects your computer, your phone, maybe a gaming console, a smart speaker, all that stuff under your roof. You know when you print a document wirelessly? That document isn't going out to the internet and coming back. It's just zipping across your very own LAN.
Now, to manage all this traffic on your local network, you need a traffic cop. Back in the day, we used something called a hub. Think of a hub as a town crier. It gets a message and just screams it out to everybody in the town square, whether they need to hear it or not. Super noisy, right? And really inefficient. That's why today we use a switch. A switch is way smarter. It's more like a mail sorter at the post office. It looks at the address on each piece of data and sends it only to the specific device that's supposed to get it. So much cleaner, so much faster.
Okay, so our packet can now navigate your local network thanks to the switch. But what happens when it needs to talk to a totally different network, somewhere else in the world? How do all these different devices, made by different companies, all speak the same language? Well, they need rules, the rules of the road.
And that's where protocols come in. A protocol is just a fancy word for a set of rules. It's the official rule book for data communication. Think of it like the grammar of the internet. It's what lets a brand new phone in Tokyo have a perfect conversation with a dusty old server in Ohio. Honestly, without protocols, the internet just wouldn't work. It would be a complete mess.
The king of all these rulebooks is something called the TCP/IP model. Let's think of it as a 4-step handshake, or like preparing a package for shipping. Step 1, the application layer. This is your web browser creating the request, like writing the letter. Step 2, the transport layer. This takes your big letter and breaks it down into smaller, numbered packets. It makes sure everything is reliable. Step 3, the internet layer. This is where we stick the to and from addresses, the IP addresses, on each of those little packets. And finally, step 4, the network access layer. This is what actually sends the packet on its way, either over your Wi-Fi or through a cable. And just like that, it's off.
So our packet is all bundled up, it's got its address, and it is ready to roll. It's now leaving the cozy confines of your home network and hitting the open road, the great big internet highway.
So what exactly is this highway? The internet isn't some single giant thing controlled by one company. It's literally a network of networks. It's a massive web that connects millions and millions of smaller LANs, just like yours, all together into what we call a wide area network, or WAN. It's absolutely huge.
Okay, so how on earth does our tiny packet find its way through this gigantic web? The answer is routers. Your home has one, and the internet is full of them. A router is basically the traffic director of the internet. It sits at the crossroads where different networks meet, it takes a quick look at the destination address on our packet, and in a fraction of a second, it decides the best and fastest path to send it down next.
It's making these decisions constantly to keep traffic flowing.
So after hopping from router to router, maybe bouncing across countries or even continents in just milliseconds, our little packet is finally nearing its destination. Client meets server. The final stop is in sight.
And this is where we meet the most common relationship on the internet, the client-server model. It's super straightforward. Your device, your phone, your computer, is the client. You are requesting something. The destination, the computer you're getting the website from, is the server. It's a powerful machine whose whole job is to store stuff and, well, serve it to clients when they ask.
So pretty much everything you do online, web browsing, checking your email, using the cloud, it all runs on this client-server model. It's centralized, but it's not the only way to do things. There's also the peer-to-peer or P2P model. In this setup, there's no central server. Everyone's a client and a server at the same time. All the peers are equal. It's completely decentralized. This is the tech behind things like file sharing with BitTorrent or even blockchain. Success! Our packet made it. And of course, a whole bunch of response packets made the return journey to bring that web page back to you. But how good was that journey? Was it fast? Was it responsive? Let's talk about how we actually measure network performance.
First, we have bandwidth. The best analogy for this is to think of a highway. Bandwidth is the number of lanes on that highway. A 10-lane highway has the potential to handle way more cars than a 2-lane road, right? Same thing here. Higher bandwidth means you have the capacity to send more data at once. It's all about the maximum potential.
But, as we all know, potential isn't the same as reality. That's where throughput comes in. Throughput is how much data actually makes it through successfully. So if bandwidth is the number of lanes on the highway, throughput is the number of cars that actually get to their destination during rush hour with all the traffic jams and slowdowns. Throughput is your actual, real-world speed.
And last but not least, we have latency, which is also called delay. This one is simple. It's just the time it takes for one piece of data to get from point A to point B. We measure it in milliseconds. And for some things, low latency is everything. I mean, have you ever been on a video call and you keep accidentally talking over the other person? That annoying delay? That is high latency. You might have all the bandwidth in the world, but if the latency is high, things just won't feel responsive.
So let's just quickly recap that whole incredible journey. A single click from you created a request. That request got packaged up according to the rules, the protocols. It was guided through your home network by a switch, then launched on the internet by your router. It hopped across a bunch of other routers around the world, found its server, and then the server sent all the information right back to you. Whew!
And remember, this whole process happens billions upon billions of times every single second, all across the globe. It's mind-boggling. And it leaves us with one massive final question to think about. With more and more devices coming online every day, our cars, our homes, everything, how in the world do we keep this unbelievably complex journey secure, fast, and reliable for everyone? That right there is the biggest challenge for the future of the internet.